All right, good afternoon, everyone. Thank you for joining us. This is Sarah Davison with Viavi Solutions Marketing. I want to thank you for joining our call today on the fundamentals of auto test. We have a lot to share with you, but before we begin, this webinar is being recorded and will be available for you to review or share with your teams in approximately 24 to 48 hours. And now I'd like to turn it over to Dave Hansen.
So welcome again to today's installment of our new webinar series that we're doing. If you signed in for the last webinar, you know we went over the basics of digital radio testing, kind of did a compare and contrast with analog radio testing, and today we are going to focus on auto test. So we talked a little bit about auto test last time, but this time we're going to get into it a little bit deeper. As Sarah said, we will be answering questions at the end of this session. And if we're not able to get to your question today, then we'll be able to, we'll go ahead and do that offline later today or shortly after. So once again, thank you for joining us. Online with us today, we have, of course, myself, Dave Hansen there on the left, Bill Nichols and Mike Fortna. Between the three of us, we make up the team of field applications engineers here in Wichita, Kansas, supporting radio test sets for Viavi. If you've called and requested tech support, there's a good chance you have spoken to one of us or our tech support team. And there you can see our email addresses. So if you have questions that you're not able to ask today, or if you think of something later on, you're driving home this evening and you think, oh, I should have asked about this, go ahead and you can screenshot our email addresses there, or if you want to get a hold of our sales team, they can direct you to us as well. So the point of that is if you have questions, please do ask them. That's why we're here. So today we are going to talk about auto test, and I guess a little more specifically, we're going to start out talking about benefits of auto test. So why you should be using auto test, why auto test can make your business more effective and more efficient, and how it can help you. And then we'll start talking about auto test itself and how we can make auto test better. So once you have auto test installed on your 8800SX or your 3920B, there are things that we can do to make the process more effective. So there's some do's and don'ts that we'll go over. One of them is cable loss, and I will talk, I suppose, at length about cable loss, but we'll also talk about external attenuation. External attenuation sometimes is needed if we're testing high power radios. We want to be able to test those radios continuously, not test a radio and then wait a period of time for the test set to cool down before we test the next radio. So external attenuation can help us with that. Power supplies, and I guess really in a broader sense, supplying power to the radio, whether it's a portable or a mobile. And in that, we'll talk about battery eliminators, which we of course encourage the use of, wires that you're using to connect to your radio, connectors, voltage, et cetera, et cetera. Next, we'll talk about some things that can affect our sensitivity testing. Of course, when we're testing RF sensitivity, receive sensitivity, we're looking at a very low level. So any leakage that is making its way into the radio will or can have an effect on our ability to test its sensitivity. So we'll talk about what we can do to mitigate the issues that come with that. One of the things we run into from time to time is alteration of the pass-fail limits. So there are some settings that we sometimes need to change, but there's also some settings we probably shouldn't be changing under normal circumstances, and test limits or pass-fail limits is one of those things. Interpretation of test results. So one of the neat things about auto test is that we are able to store those test results on your test set. Immediately after we run the auto test application for a given radio, we store the results from that radio, from that test. Of course, each time we run that radio, we're going to store another set of results, so those just accumulate. The nice thing, of course, is we don't overwrite the previous results, so you always have that historical data. But what you do with that data afterwards sometimes can be real handy in determining cause of failure, trends, that sort of thing. We'll talk about breakout boxes, accessories, things that you need to connect to the radio in order to get audio in and out, programming cables so we can communicate with the radio, things of that nature, and where you can get those items. And then we'll finish up with auto test updates. Very briefly, we'll talk about how that process works and where you can get those updates for your 8800SX and 3920B. So when we talk about benefits of auto test, there are a number of benefits really, but ultimately the goal is to make you more valuable to your customer, so your service more valuable to your customer. And we do that in several ways. The first is all of our auto test applications are tested and evaluated by the radio manufacturer to ensure that what we're doing accomplishes what they want to accomplish in the test and alignment of their radio. So what that means is we're not just pulling tests and procedures and things out of the air to test your radio. Okay, we're doing the things that the manufacturer would have you do if you were aligning or testing that radio manually. The difference, of course, is that we are doing this in an automated fashion and thus making you more efficient in the process. One of the really great things about auto test, and this goes in, I guess, hand in hand with this third item here, removes human factor, is that we gain a lot of consistency by automating this process. When you have a person, a technician sitting there doing these alignments manually, one, they're tied up in front of that radio the whole time, but maybe more importantly, every technician is going to view a meter a little bit differently. Right, so we got technicians that have been testing radios for 50 years, and this is the way they've always done it. So this guy's always aligned the transmit power a little on the high side because he wants to make sure that the user gets a little bit better range. Or the next technician comes along and says, well, I want to conserve battery life, so I'm going to lower that transmit power a little bit and take it easy on that PA. Someone else, when we talked about analog alignments last time, and there are a lot of there's a lot of leeway in analog, so you can get away with a lot of misalignment in an analog radio and still have that radio perform in a seemingly satisfactory manner. With digital, that's not always the case. So if you had someone, say, adjusting the deviation on a radio, and they are used to adjusting analog radios, and they always set them just a little bit high, when we get to digital radios, that can have a huge detrimental effect on the range, the sensitivity, the effectiveness of that radio in use. So when we take that human factor out and use a computer to perform these alignments, you're going to get the same alignment time after time after time. And that means that every radio that's out there is going to perform the same way. That means the users of that radio are going to know what to expect from one radio to the next. You don't want to have a user that has one radio that works a certain way and the next radio that's issued to them is completely different. You want that experience to be the same from radio to radio. So being able to, again, gain that consistency that comes with an automated test, it can be huge in how that radio performs. By automating this process, we take a lot of the skill required and the knowledge and experience that's required to align these radios effectively out of the formula. So what that means is you can have your new technicians. Maybe you got technicians that are right out of school. They know all the theory behind RF, but they don't know, they haven't been in the real world yet, so to speak. So you can have them go through and do these alignments and gain some knowledge about the radios and help understand how the radios are working, what failures exist, things of that nature. And while they're doing that, your more experienced technicians can be out in the field troubleshooting or hunting for interference and doing things that require a slightly higher skill level. So it really allows you to allocate your resources more effectively, more efficiently, and make better use of the technicians that you have. Of course, these test results are stored in a text file. So once you have completed an auto test alignment or test of a radio, we're going to store a test results file on the unit, and it stays in there as a text file until you delete it. And like I said before, these are unique to each run. So that means if you run the same radio 5 times, you're going to have 5 different sets of results in there. That's real handy sometimes when you're trying to troubleshoot a problem, because you can go back to the previous run and see if something changed, or if a fault maybe moved. So you had a fault here, and now that thing's passing, but the next frequency is failing, or something of that nature. When you run into stuff like that, sometimes that can help you diagnose the problem, or if you're not able to diagnose the problem, maybe at least it gives you the opportunity to give that feedback to the depot so that they know what it is they're chasing. And then, of course, if the more information you can give to them, the less likely you are to get a radio back with no fault found. Higher productivity and quicker test times. Yeah, so when we go through and we run these tests on the 8800SX and the 3920B, typical time, and it varies from radio to radio, of course, but a typical time might be 10 or 15 minutes for us to go through a complete test and alignment of a radio. And we've talked to technicians over the years, and we say, well, auto test can speed up your testing, and they say, I don't need auto test. I can test this radio in about 5 minutes. Well, there's a big difference between what a person can manually do in about 5 minutes and what auto test can do in 10 or 15. We're not really comparing apples to apples there. Okay. Now, the last time I manually tuned a radio, because it's not something I enjoy doing anymore, but it took 45 minutes to an hour to go through that full alignment. Okay, that same radio in auto test takes less than 10 minutes. So if you stop and think about that, what's happening there, and again, that's more of an apples to apples comparison. Okay, a full alignment using the tuner software for the radio versus a full alignment using auto test. It's what, 5 or 6 to 1 ratio as far as time goes. So in that same amount of time that I did that one radio, if I'd had auto test at the time, I could have gone through and tested 5 or 6 radios. And again, that's huge in terms of productivity. Now, when I talk to someone, they say they can test a radio in 5 minutes. We start talking about, well, what is it you're doing with that radio? What tests are you running? And what it really comes down to is that they're picking a few things that they think are key parameters. So they may check transmit power on 1 or 2 channels. They may maybe do a sensitivity test at 1 or 2 channels, check deviation, whistle in the radio, check your peak deviation, that sort of thing. But you're really not able to go through and do a full check of that radio. And here's the thing, if you're testing that radio at 1 or 2 frequencies, that's fine for those 1 or 2 frequencies. But when you issue that radio, the end user may not be using those frequencies. So let's say you test the radio in the middle of the band, and they're actually using it at the fringes. Well, one of the things we've seen historically is that radios tend to perform great in the middle of their frequency range. You get them out into the edges of that frequency range, and all of a sudden you start seeing a roll off in sensitivity, or you see their transmit power kind of starts to drop off a little bit. So you see those things, and you kind of start to realize that it's important not just to test the radio where it's going to work, but to test that radio across its entire span. That way, no matter where the end user's using it, no matter which frequency they're using, it's going to work. They're going to be able to rely on that communication back to base. So we'll talk about manual versus auto test a little bit more here, and this is kind of to drive home the point of efficiency. Little Jimmy over here sitting here kind of bummed out because he's sat at his bench for 8 hours today, and while he did take a lunch and a couple breaks, all he got done in those 8 hours was sitting there and testing these 8 radios. And it's a long, tedious process and not a lot of fun. The other guys are out, doing exciting things like hunting interference, and that's all he did. Tested 8 radios. So that was a productive day for him. Now, Bob over here, on the other hand, looking pretty smug, kicked back, because he got done in that same amount of time using auto test 4 times the number of radios. So 32 radios, and again, these are kind of typical numbers. It's not going to be the same for every radio, for every manufacturer, for every model. If you have a radio that's really badly aligned to begin with, it may take a little longer to align than one that's pretty close. So, like I said, this may vary a little bit, but the idea that auto test is going to be consistently faster than the manually testing is generally true. Now here's the cool part. While Bob was testing these 32 radios, he was also able to do some other things. So while those radios were being aligned, he went and installed a light bar. He made some phone calls, got a hold of some customers, set up some appointments to go do some new installations. Maybe he went out and grabbed his other service monitor, his other 8800, and aligned a duplexer. There are lots of other things that he can be doing while those radios are testing. He doesn't have to sit there in front of them and monitor them and babysit them and tune, move soft pots manually. Okay, this is all happening on a bench by itself. So really, what that means, versus Jimmy over there, he's got 8 radios done. Bob here's got 32 radios plus another man day worth of work done. So really, what, five Jimmys all rolled into one there. So that really illustrates how much more efficient a person can be if they have auto test on their site. They can be testing radios, they can be doing all these other tasks all at the same time, and at the same time doing more radios too. So cable loss is one of the things that we'll start talking, I guess, now about some of the do's and don'ts here. Cable loss is one of those things that I do spend a lot of time on. If you've ever talked to me on the phone, you've probably heard me talk about cable loss. And the reason I talk about it, and the reason it's so important to me, is that cable loss is the single most significant issue or cause of auto test failures, false failures, or inaccurate alignments, or just generally, I guess, issues that people have with auto test or testing the radios in general. It's something we don't give a lot of thought to normally, right? We're testing radios, and a lot of times we're just going, is there power there or not? And then in that case, of course, how much cable loss isn't real critical. But when we start talking about alignments of these radios, the alignments of these radios are far more critical today than they were 15 or 20 years ago. And so because of that, because the alignment's so much more critical, it's real important that we get everything as accurate as we can. Since cable loss leads to inaccurate measurements, sometimes that means that our radios will fail even if they're not actually bad. So cable loss is going to affect transmit power. It's also going to affect sensitivity. Typically we don't see sensitivity failures due to cable loss, but it can happen, and I have seen it happen. If you have a radio that's right at the edge of its spec for receive sensitivity, it doesn't necessarily take a lot of loss of signal to push it over the edge, push it past that line. So having that cable loss compensated can prevent false failures there too. Power is pretty obvious. If you have a certain amount of loss in your cable, like I said, that should be pretty straightforward. Now, as an example here, I've got a piece of RG400, 4 feet long. This is pretty common. I see this in a lot of shops. You may have these cables in your shop. They're commonly available. They don't cost a whole lot of money, so they're like I said, they're pretty well liked. But this RG400 has about 14 dB of loss per 100 feet, and I'm looking at that at 1,000 meg. And of course, the higher in frequency you go, the more loss there is. The longer the cable is, the more loss there is. So there's a lot of factors that affect that. But as an example, at 1,000 megahertz, 4 feet of cable has a little over half a dB of loss, about 0.6 dB, which doesn't sound like a lot, right? We think of that and we go, well, it's less than a dB. How bad can it be? But when we put that into percentage, now we start to see why that can have such a huge effect on our measurements. So 0.6 dB is roughly 15%. 15% at 100 watts, if we're testing 100 watt radios, means that we're only going to see 85 watts of that transmitted power. Now, if our spec for that radio is plus or minus 10%, That means we have to be between 90 and 110 watts. You can see that before we've even gotten out of the gate, we're failing this radio, okay? Even though the radio is transmitting its full 100 watts, we're only seeing 85 watts of it, so we're going to fail that radio. Now, I had this actually happen with a customer in Costa Rica. I was visiting their site. They had 100-watt radios, 100-watt repeaters they were testing. It wasn't auto test, but it's the same idea. 100-watt radios, and where we had to connect to the radio was it was on the back of the rack and was up towards the ceiling. And they had the service monitor sitting on a chair in front of the rack where they could control the radio. And so, of course, had a cable that went around and up and snaked through there to get to the radio. And when we tested transmit power, we were only measuring about 75 watts, okay? Now, what do you do when your radio is measuring low? You try to bump the power up, right? So they started adjusting their soft pot values, and they adjusted it up and up and up and up, and the radio starts going into compression. About 95 watts, it starts going into compression, and that was as much as they could get out of it. So about 95 watts. Now, when we swept the cable or measured the cable loss, we found that there was about 1.2 dB of loss, so 24%. Now you can see where this really starts to have an effect. When we put that cable loss in and we were able to compensate for that loss, we were actually putting out about 125 watts from that radio. Obviously, that's not good for the radio. In some areas, some jurisdictions, that may get you into trouble, may get you a fine from somebody. So it's important that we make sure these measurements as accurately as possible. And this is a manual test where we have the ability to think through it. Auto test doesn't think through these things. It says the radio is good or it says the radio is bad, and that's all based on the measurements it's able to make. So we need to make sure we put these cable loss values in. On the 3920, we have a built-in automated test or measurement for that cable loss. It's real handy. We go into auto test, we click on the edit specs soft key, go to the cable loss screen, and then select the table that we're going to characterize or store, and then just follow the on-screen prompts. The neat thing about this is in the background, we're actually sweeping this cable from 100 megahertz out to 1,000 megahertz. So no matter which band that radio is, it's automatically measuring that for you, okay? Once we have that cable characterized, we can select that cable and it's going to automatically use whatever frequency, whatever loss there is for that frequency, it's going to automatically use that. And in doing so, it's going to make sure that it's measuring transmit power correctly. It's going to make sure that sensitivity measurements are made correctly. All that stuff is done with that cable in mind. In the background, what's happening here is we're actually setting up the tracking generator. Okay, we'll measure a reference cable, and we call it a reference cable not because it's anything exotic or special. It's just what we use to establish a reference, okay? And then you can see here we add this adapter and our radio testing cable to that first cable. So we don't remove the first cable, we add to it. When we do that, of course, when you add a second cable, the level is going to drop just a little bit, or well, we hope a little bit, and whatever amount it drops is what we attribute to the cable loss of that cable, okay? Once we have that stored, like I said, then we can go through and use that cable indefinitely. Now, most of our auto test applications on the 3920B give you at least 3 cables that you can store. Some give you 5, up to 5. So that gives you the ability to store a short cable for on the bench. Maybe you've got a 15-foot cable that you're using in the car, and that's fine. It doesn't matter which cable you're using as long as you have the ability to store it and it's being compensated for. As long as it's being compensated for, you're good to go. On the 8800, we have the same ability to measure the cable loss, or a similar capability. It's not automated the way the 3920 is, though. So on the left there, you see the screenshot of our web page and that document labeled Determining RF Cable Loss on the 8800 series. So you'll find that under the literature section of the 8800 web page. You download that and you get this PDF that walks you through the process of characterizing that cable. Now, like I said, it's a manual process. It's not fully automated the way the 3920 is, but it's basically doing the same thing. So we set 3 different frequencies. Usually we pick the middle of each band, and we establish a reference with our reference cable. We add our second cable, our radio testing cable, to that, and we see how much the level drops, and we note that level, and we call that the cable loss for that cable at that frequency. Like I said, it's not automated the way the 3920 is, so we need to write that down. But as long as you have those values handy, and what I usually do is label each coax, label maker, and label each coax with the frequency and loss. And then when I go into auto test here, you can see we go to the cable loss screen and enter these values. I just have the loss there on the cable itself. I can put into these 3 fields, and I'm done. Now the 3920 stores those cables per radio family, with a couple of exceptions where we can copy from one radio to another. Most of these auto test applications on 3920, the cable loss is per radio family. On the 8800, we store it kind of permanently, I guess you could think of it that way, I guess. So no matter which radio you're testing, you just select, or you have that cable loss in there already, and it's going to use it until you change those values. One of the things we run into from time to time is errors in measurements caused by faulty cables and connectors. And sometimes that means that the cable itself has been damaged. So maybe it was slammed in a drawer somewhere and it's pinched. And typically that type of thing, it'll cause a high VSWR, and we get a change in the frequency response. Sometimes it's enough to actually cause the radio to fault for high reflected power. So there's lots of things that can happen, but it usually results in some sort of frequency response issue, okay? If we are measuring transmit power, we'll see that roll off sometimes. We'll be able to look at that and go, well, at this frequency, power was good. At this frequency, power was okay. By the time we get to this other frequency over here, it's way low. Sometimes it doesn't show up there. Sometimes we're able to make alignments and make up for it. So we can, we went through the auto test or the cable loss measurement on the 8800 there. We can also go out to the web and we can look up the specs for a cable, and we can calculate what the loss should be. And that is typically pretty close. But what that doesn't tell us is whether the cable we have in our hands is actually good. So even if you're able to look these things up, it's still a good idea to go through and characterize the cables you have, the attenuators you have, make sure that the connectors you have are good. I've had situations where a customer had a cable that it was a good cable, right? Everybody I talked to, I asked what kind of cable they have, and they say it's a good cable. So they had their good cable, and they we're trying to test the radio, and they kept getting these failures. And they're pretty significant failures, way low on power. Sensitivity was awful. We talked about it a little bit. And I said, well, let's characterize this cable, see what our cable loss is. And they hooked it up, and they didn't get any signal into the service monitor, nothing we were seeing. And ultimately, of course, we figured out that the cable was bad. Turned out one of the connectors was actually missing the center pin. So that sort of thing can happen, and that's not something that a calculator can tell you, okay? One of the things I've run into is people, when they're doing a lot of testing and they've got their N connector on their cable, of course they got a BNC or TNC adapter, or usually a BNC adapter on their radio, and they don't want to take the time to go find the right adapter to get to hook that N connector on to that BNC connector, and they'll just take that N connector and shove it in there. And that will work for a while. The problem with that is that the N connector has a larger center pin, and what happens to the female BNC connector, and again, I have TNC in there too because we do use TNCs on the 3920B, but what happens is the fingers on that socket get splayed out, and then they no longer make contact when you put a BNC or TNC connector in there. And you don't notice that right away, okay? So you're using your N cable and you shove it in there and everything seems to be fine, and then you start trying to do things with your other cables, and all of a sudden you're not getting a signal through there. And it's once you see it, it's pretty obvious, but it's happened to more than one of my customers, and I don't want that happening to you, so don't do that. Also, don't shove UHF connectors into N connectors. That also results in bad things happening. So while we're talking about loss and compensating for loss, both 3920 and the 8800SX will handle 50 watts continuously into their TR ports. When we start going above that, though, we start dealing with a duty cycle. So if you're testing a 100-watt radio, you're limited to somewhere probably around 30 seconds of continuous transmitting before we kind of want you to stop doing that for a while and let us cool off. That's okay if you're manually testing radios. When we are in auto test, though, and we start going through, say, the transmit power alignment, we have the radio keyed up for quite a while, and that allows heat to build up inside the service monitor, and eventually we trip an alarm and we say, hey, stop transmitting for a while. Now, when you're manually testing, not a huge big deal, I guess. If I mean, you're going to spend an hour testing and aligning this radio anyway, so what's another couple minutes? If you're running auto test, a couple minutes waiting for the unit to cool down, is a significant portion of that time that it would normally take. Not only that, of course, it's like anything. The more times you hit that limit, it's like your car, your motorcycle. You sit there and bang the rev limiter over and over and over again. You're shortening the life of that motor. We don't want to, I guess, stress the internal components any more than we have to, even on things like 3920 or the 8800. So it's a good idea to pad that signal down a little bit, and we sell a 6 dB attenuator just for that. 6 dB brings the power down to half, so if you were, say, testing a 125 watt radio, brings it down to 37 watts. So you're able to actually continuously test that radio one after another without having to worry about overheating the TR ports of these units. The neat thing about both of these models is that we give you the ability to put in that external attenuation separate from the cable. So you don't have to go through and characterize the cable with the attenuator. We can do the cable loss, and then we can characterize the attenuator as well. Keep those two values separate, just put the attenuator in when you need to. Now, I do have customers that will go ahead and sweep the attenuator and the cable at the same time. And if you always have that attenuator hooked up to that cable, that's fine. That's a neat way to do it because you don't have to put in a manual or manually put in a number, but it does give you the option of doing so when you need to. Now, I do recommend characterizing the attenuator as well. Generally speaking, a 6 dB attenuator, a high power attenuator like that is relatively flat in the frequency range we're testing. But it's always a good idea, just like with the cables, if you have a cable that should have a half dB of loss in it, that doesn't take into account any damage to the cable or broken connections, things like that. The same thing can happen with attenuators. So if you don't test that attenuator and you had a bad connector on it, for example, you wouldn't know that until you actually dug into why your radio was failing. So it's still a good idea to characterize that attenuator and make sure that the loss is what you think it is and record that value. So I'll get off my cable loss and attenuation soapbox for a little while. Supply voltage and current, we got to feed these radios. We've talked about what comes out of the radios. Let's talk about what goes into them now. Supply voltage and current. It seems like a pretty common sense thing. You got to have a power supply that's feeding this radio the correct voltage and the amount of current that it requires, but it happens more and more often, it seems, where people are not aware of what their radio requires. So, refer to your radio's documentation, see what kind of current it actually draws, see what voltage it requires for alignment, and make sure you're using a power supply set to that voltage. In addition to the voltage, of course, we have to deal with the amount of current that the radio is going to draw, and of course, when we're going through the alignment, there's times where we may draw more current than the radio normally would draw. Okay. Now, what happens when we draw current through a wire, of course, is that the voltage drops across that wire. So there's also, as far as the power supply goes, it's a good idea to have, if you can. I know it costs more, but it's a good idea to have a power supply with a sense line that you can monitor the voltage at the radio end of that wire harness. If you don't, at the very least, make sure you're using heavy enough wire to support that radio. Now we talk about current limiting because current limiting, if you have a 50 amp power supply, but you've got the current limiting set to 5 amps, it's not going to act like a 50 amp power supply. So we need to make sure the current limiting is at least higher than set higher than what the radio is going to draw. So those are things related to the power supply itself. The next part is making sure that the power is getting from the power supply to the radio. And that means using good connections. So I've had customers who have used power supplies with banana jacks, and that's great, it's convenient. But the banana jacks a lot of times don't have a very big opening for wire. So in this case, they had 8 or 10 gauge wire, but they couldn't fit very many strands of that wire into the banana jacks, so they just trimmed back a bunch of those strands, and they ended up with like 3 strands of wire going into the banana jack. So not a lot of current capacity in that short span of wire. Now, normally I wouldn't expect that to cause a huge problem, but in this case it actually caused enough voltage drop that the radio was sensing that. Radios monitor the voltage sometimes, and if they do, and I see that lower voltage, they may go back into a lower power mode. And when that happens and we try to align the high power, it doesn't work very well. So make sure you're using good connections and that your connectors will handle the current you're trying to push through them. At the same time, use heavy enough wire. And again, it seems like it should be common sense, but if you're testing a 100-watt radio, using 24 gauge wire is not going to cut it. And I know sometimes I joke about that, but I've actually had situations again where customers have been set up that way. You know, have a high power radio and they'll be using real thin wire because that just happens to be what they had available to them in the shop at the time. And ultimately what happens is we fail the radio because we can't get the power high enough with that much voltage drop through that wire. So make sure your wire's good, heavy, and the connections are also up to par. Now, when we test or do PA bias alignment on some mobiles, we do need to measure the current draw. So we use what's called a current shunt to do that. And what that allows us to do is measure high amounts of current with a voltmeter. When we connect this, that seems to be a kind of a confusing thing. It's once you understand how that current shunt works, it makes sense. But we have to splice into the positive battery connection to the radio. So what we do is we take that positive connection from the power supply, go into the red connector on a current shunt. The current shunt gets plugged into the DMM, and then we come out the black connector on the current shunt into the radio, and the current then goes through that current shunt, and we can measure it. It's like I said, pretty straightforward once you understand how it gets connected, but I know a lot of people get confused by that, so I want to make sure we get that in here. Autotest does look for that, so if we go to measure the current draw and we don't detect any current draw, we will automatically skip that alignment. So it's not a critical thing, and in fact, some manufacturers will tell you the PA bias alignment does not really need to be done, and in some cases shouldn't be done unless you've replaced boards. But I know that a lot of my customers have told me that, yeah, they know that, but they still want to do it because, well, basically because they can. So we talked about mobiles, or I spent some time talking about mobiles, I guess. Let's talk a little bit about portables. We recommend the use of a battery eliminator. The OEMs recommend the use of a battery eliminator. And the reason for that is battery voltage is not a constant. Battery voltage, as we are doing our testing, and the longer we have that radio keyed up, that battery voltage is going to drop, it's going to sag. And when that happens, it affects how the radio's tuning works. Again, kind of seems like common sense to some, but it does make a difference. It makes a huge difference. I had a customer here not too long ago who had a handful of radios. I think it was like 6 radios that they sent back to depot because they were failing transmit power, and it turned out that they were using an old battery. Battery eliminators eliminate that issue because they set the voltage, and it stays constant. When we're testing these radios and you have an old battery and that battery voltage changes, we don't know that. Okay? We don't have a way of monitoring that, so we are depending on that voltage to stay constant. Another issue we've seen is that the alignments and tests sometimes have to be done at a specific voltage, and even a fully charged battery may not be that specific voltage. And in one case that I know of, the battery voltage when it was fully charged was above that voltage, and it actually caused failures. So we had a DMR radio. Of course, DMR is a 2-slot TDMA signal, and so uh, when that transmit burst came up, it would cause a little glitch on the rising edge and would cause it to fail magnitude error. So even brand new batteries cannot be relied on to provide the correct voltage and constant voltage that we need for these alignments. Now, I understand not every radio has a battery eliminator available. And in that case, I would certainly recommend using a fully charged new battery, but like I said, it's not the best way if you have a battery eliminator available. Okay. So when we test receive sensitivity, we're sending this radio a very low level. We talk about receive sensitivity. A lot of times we're talking about negative 116 dBm. Some radios test at negative 121. So we're talking about a real small level. And while we are direct connected to the antenna port of that radio, the radio could have leakage. And this is another one of those things, and I think most everything in this presentation is stuff that we've run across in real life. So we've had situations where we test a radio and we fail receive sensitivity at one frequency, and every radio fails at that frequency, and it fails badly. And it turns out that there's something in the air. And it could be that there's a repeater next door. It could be the repeater in the shop. But something outside of the radio is getting into the radio at that frequency and causing it to fail. So noisy RF environment is typically the cause of that, and it doesn't have to be at that frequency. It can be an adjacent channel. It could be some other frequency that's just close to it, but real high power. Okay, you can cause a lot of intermodulation in a radio, and of course, intermod's going to cause things like bit error rates, or if you're testing analog radios, can cause SINAD failures. So there are a lot of things that can affect that, but ultimately what happens is the radio it fails sensitivity, and that's bad. So now on this screenshot that I've got here, this is I did this screenshot here this week, and this is a live. This is real life. This is what the RF spectrum looks like at my house. So at 764 megahertz, which happens to be a frequency we test receive sensitivity at. You can see at the moment, it was about negative 80 dBm, but that signal was fluctuating, and it was bouncing up to about negative 70. And depending on where you are, depending on how close the tower might be, that signal may be somewhere else, maybe a little higher. I think that's the middle of I want to say that's band 14 LTE. So there's other signals out there, not just our signals, but other signals out there that can interfere with these measurements. And when that happens, again, it just shows up as a failure. And the only thing we can really do about that, we can't. A lot of times we can't really pick another frequency to test sensitivity at. So the only thing we can really do about that is to eliminate that interference. So you can go down to your nearby cell tower and kill their generator and cut the power lines, which I wouldn't recommend doing. Or we can build some sort of shield around the radio to protect it or isolate it from that signal. Now, I've had customers address this different ways. I've had some customers that were able to get a static bag and stick the radio inside the static bag, and that was enough to reduce the signal from outside enough for it to pass. I've had customers stick the radio inside of a filing cabinet or under a metal trash can. Lots of different things that can be done. I had one customer took the radios and the service monitor to a basement closet where he had no cell service and no radio reception, and all of his radios passed great there, and nobody bothered him for the rest of the day. But the point is, there's more than one way to address that, and this definitely is an issue that we run into. Like I said, this is my house. Here's let's see. I guess I don't have it up there. We had a screenshot from a customer in California, out on the coast there, that his spectrum actually looked way worse than mine does there. So the other thing that I was going to show was some interference that was kind of intermittent. So if you have I've had customers that have multiple benches in the shop there. One technician's over here testing his radios manually. We got auto test running over here, and just when that other technician would key up his radio, it would cause failure. So intermittent things, but it was always the same frequency. So that's something to be aware of. If you can address it, that's great. I've had some customers tell me that there's just no way that they can address it, and they just know, now that they know that that's the failure, and they're able to prove that that's the failure, then they can overlook that. That's kind of up to you. That's your shop's philosophy, and like I said, kind of however you want to deal with it. Pass fail limits is something else I want to talk about just briefly. Like I said, we have to go in and adjust some of these parameters sometimes. This is on the edit spec screen on the 3920B, and I've got one of the configurations up there for the 8800. All the values that are in auto test are just like the test itself, approved by the manufacturer of that radio. So when they come back to us and say, these are the power levels that we should be testing at, these are the tolerances, that's what we put in here. So most of the time, we don't need to change those. Occasionally we do. Occasionally we have a radio that's programmed to transmit a different power level, and we need to go in and change that, and that's fine if that's the case. But one thing we don't want to start doing is looking at our tolerances and say, well, this is, you can see here the low power has a tolerance plus or minus quarter watt. You don't want to go in there and say, well, a quarter watt's good. A tenth of a watt would be even better. And the reason I say that is because the tighter you make that spec, the tighter the alignment has to be. And sometimes the alignment steps from one soft pot value to the next don't allow that small of an adjustment. So you could actually have a transmit power that was too low, and you adjust that soft pot value up one value, and now the power is too high because we can't hit that fine of an adjustment. So it's best to leave those at their default values. If you have questions about that, if you have questions about, my radio is failing and I think it's the wrong value, reach out to us and we'll discuss it with you. And if there's a different value you should put in there, we can let you know to do so. Okay, so yeah. So once we have these results, we've gone through auto test, we've completed everything passes or something fails, whatever the case. So we store those results on the test set itself. So the 8800 or 3920 is going to have those results stored. We can copy those off via USB or over a network connection, and we can archive them, we can print them, give them to the customer. A lot of times what we can do with them is use them for diagnosis. So you can see here we actually show that there was a failure in this particular set of results for high power. And we can look back at the header of this set of results, and we can see what radio it was, and we can see what firmware, the 8800. So there's a lot of traceability that goes with these results. There's another thing that we can do with these results too, though. Because we have all of the tests stored in there, we can look at those results and we can say, well, this transmit power failed. Why did it fail? So we go to that test, we look at that data, and we evaluate it, just like you would if you were manually testing a radio and you have a failure. You start troubleshooting, right? So we look at that data and we say, well, why did it fail? Now, I had a customer that I mentioned earlier, that had sent half a dozen radios back to depot, and when he tested them, they all failed transmit power. When the manufacturer tested them, they did not fail. So they send the radios back to this customer, the customer gets them back, and they still fail transmit power for him. So he calls me and says, hey, what do we do about this? And I had him send me the results, and we looked over these results, and we could see that transmit power was in fact failing. And at every frequency, the longer we had the radio keyed up, the lower that power was. Now we have a feature called extended logging that we can turn on, and it stores all of those adjustment steps as well. And when we look at those, we could see that we were actually trying to adjust the power up, but every time we'd make an adjustment, the power would either stay the same or would drop. So at that point, this turned out to be a battery thing. That's why I was able to say, well, it looks like your battery's dying. Do you have a battery eliminator? No, it doesn't have a battery eliminator. Do you have a better battery? Well, this is a good battery. It's a shop battery. It's a good battery, just like the good cables, right? But he got another battery, hooked it up, and everything all of a sudden passed. So a good example of why not to use batteries instead of battery eliminators, and a good example of how these results can help troubleshoot problems that you see. So required hardware, when you run these radios through auto test, you're going to have some hardware besides the radio and the test set. Okay. Some of this is going to come from us. Some of this is going to come from the radio manufacturer. So breakout boxes, for example, we need to get audio out of the radio, and sometimes requires a breakout box or breakout cable. We do not provide those. That has to come from the radio manufacturer. So contact your dealer or your radio rep and ask them for the part number for that, and then order that from them. Some radio manufacturers don't sell breakout boxes. That they put documentation in their maintenance manual, the service manual, that says, here's how you break the audio out. And you take a programming cable and you drill some holes in the side of it and you solder some wires. Sometimes it's a fancy cable that has molded ends and all that. Other times it's less sophisticated looking, but ultimately, like I said, that information has to come from the manufacturer of the radio. And then programming cables themselves, most of the time, I know there's some exceptions of this, but for the most part, we're going to use the radio's programming cable to connect the radio to the service monitor, and that's how we're going to communicate with the radio, put the radio into service mode or maintenance mode. We're going to send the calibration data to it back and forth between the two. And again, we don't sell the programming cables for the radios. That's something that has to come from the OEM. Wire harnesses are something that you may have to make. It depends on the radio. Again, certainly if you're using a current shunt, you will have to splice into the positive battery cable. But in general, of course, most radio manufacturers provide a wire harness. Most customers I talk to just take one of those spare wire harnesses, and that's what they use for connecting it for auto test on the bench. Antenna adapters, most, well, I don't know if I would say most, but a lot of radios will use a mini UHF connector on the back of their mobiles. I know Motorola anyway has started to use QMA adapters on some of theirs, but there's a lot of different adapters that are out there, and some of them are radio model or radio manufacturer specific. So if you are not able to find them, you can ask us, and we may have a source or have somewhere we can point you towards to find those adapters. But again, we do not sell the adapters themselves, primarily because there's just so many of them out there that different manufacturers use. And then battery eliminators, once again, not something that we provide. And again, not every radio has a battery eliminator available. But if there is one, we certainly recommend seeking it out and getting a hold of one and using it. Now, we are able to provide the antenna cable. So we have a cable that we like to use. It's about 3 feet long. There's a part number there for it, and we've had very good results for it. It's very has a very flat response, a very smooth response. Like I said, it just seems to work very well. I know there's other high quality cables out there, so you don't have to buy that from us. But we, like I said, the one we have, we're very happy with, and we've had very good results with. 6 dB attenuator, there's part number for that. Again, if you're testing 50 watt radios or below, that's not a requirement. We can test those radios all day long without any problems at all. If you're testing 100 watt radios all day long, then I would highly recommend using a 6 dB attenuator like that. And then the last thing that I guess I'll mention here would be the current shunt itself. So if you're testing radios that have a PA bias alignment, we need to measure the current draw, and that's the part number for that current shunt. Well, the last thing we'll wrap up with here, the last thing, we're going to wrap up with the last thing. That's what we're going to do, is updates. So there's a link right there. You can screenshot that, or if you want to go to the Viavi Solutions homepage and go to the search thing in the upper right corner, you can search for the models there. But kind of idea what to expect when you get there. You can see there's a software update or system software update and an auto test update. So those two are up there separately. If you do update the system software, you will get the latest auto test as well. So there's never any harm in doing that. If you already have that version, we're just going to go ahead and skip the things that are already installed and update the things that aren't. So again, no harm in doing that. It's just a bigger file. If you are one of those customers that's locked into a particular system software version, we do give you the ability down there to download just the auto test update and install it by itself. So you don't have to install the system software updates if you're opposed to doing that for whatever reason. And we do recommend staying up to date on those because we do have bug fixes and new features that are released fairly regularly. Release notes are all there as well, so instructions, et cetera, et cetera. So that's the end of what I have to say at the moment. Thank you for joining us. We're going to do some questions and answers. I know I ran pretty close to that full hour there, but Bill Nichols and Mike Fortin are online. We're going to sit down and go through these questions and see if we can't answer a few of them. Mike and Bill?
It's
Hello?
Bill Nichols here.
Okay.
Mike's probably busy typing an answer.
Okay. I know we got quite a few questions. I saw in the corner of my eye, I saw the question box kept scrolling. So looks like we had some good questions from customers.
I'm looking through here.
And just to give everybody an idea, I guess, or to let everyone know, we probably are not going to get to all of these. It looks like, it looks like Mike and Bill have been answering as we go. If there's anything that we don't get to, like I said, I know I ran pretty close to our whole hour here, but if there's stuff we don't get to, we will get back to you.
So I'll jump in. One of the questions was asking if the auto test could actually load the firmware into the radios, and that's a little beyond our scope. We have access to test and tune type capabilities in a radio, but we don't typically have access to the firmware part of the radio to where we can actually load a new version of firmware into it.
We've got a question from Brian. He's asking, he's just curious, does anyone else test new radios out of the box before deployment? And I'd have to say, I do know a lot of folks that do that. I just know that from talking to folks. It's not a recommendation by the manufacturer or anything like that, but a lot of people do test those radios out of the box.
Yeah, Christopher there on whether you should wait a while before using the auto test. All of our test sets, and this is true for pretty much any test equipment out there, there is a warm-up period recommended by the manufacturer of the test set. So in our case, we do recommend, I think it's 10 or 15 minutes for the oscillators and everything to warm up and stabilize before starting your auto test. That said, it's been my observation 3920B and 8800SX both from a frequency standpoint are very stable and very close to correct right at, by the time the interface loads and you can start pushing buttons on it, the stability is excellent right out of the box. So but yes, we do recommend a 10 or 15 minute warm-up time.
I don't believe we answered Brian's question on calibration. Should the 8800 be sent back to the factory for calibration? If so, how often? The recommendation historically has been, once a year you should send those radios in for calibration. And when you purchase the instruments new, they come with a 2-year warranty, and so you can send those in for the first 2 years and get a calibration that way also. But they should come to the factory because you really we're the only ones that have the equipment and being able to control the software of the instrument to do those calibrations, especially on the 8800. So yeah, once a year is a good idea to send those in and get the units calibrated from the factory.
Jamie, on the website, and I don't know if I can pull it up here or not. Let me see if I can pull this up. I guess I'm going off course here. You asked about the subscription to get updates. If you go to the 8800 webpage or the 3920 webpage, there is a resources tab here. No, sorry, product notifications link right there in the middle of that. And I guess I don't have any drawing tools here that I can. Oh, I do. Let me see if this works. Highlighter. Let's try that. There's a product notification link right there in the middle that you can click on. And when you click on that, let's see here. Let's see what happens when I click on it. It takes you to this screen. You can click on your 8800 series. If you guys have 3920Bs or 3550Rs or any of the avionics stuff for that matter, you can click on those as well. put your email address and name there and click on update preferences, and it takes you to the next screen, et cetera, et cetera. And then you'll get an email when there are updates for you.
We got a question from Ken. He's asking, my 3920B does not have auto test option. Does that have to be purchased? The nice thing about the 3920s is we do have try before you buy. So you can give us a call. We'll jot down your serial number of your service monitor, and we can turn those options on for 30 days. And so you can take them for a test drive. So that's an option on 3920. Unfortunately, 8800 does not have try before you buy.
Eric, as far as comparing the data between different alignments from one day to the next, for example, the service monitors themselves do not have any ability to do that. Typically, what I use, and there's different software on the web, different text editors that you can download. The one I use is called Notepad++, and it has a compare plugin that you can use to put them side by side, and you can then go by go down both sets of results that way and compare them. So like I said, the units themselves don't have that built in, but there are ways to do that outside of the box.
John's asking a question. Go ahead, Mike. Go ahead, Mike.
No, there's a couple questions here. One of them is if we have a script built for the new APX Next radios. We do have the radio, and we've tested it, and that's something that's in process. So hopefully we'll have that available in the near future. Go ahead, Bill.
Oh, we had a question on the Tate radios. John was asking, has Tate provided you with any part numbers devices for use with the auto test of their DMR equipment? If you're talking about the DMR portables and mobiles, we do have the part numbers now for the breakout box, and you do have to have the breakout box to run those DMR radios. John, we've got your email address, and we'll send you the information on that so you can pick up those devices and the programming cable itself.
And Brian, you asked a question if anyone else tests radios new out of the box, and yes, that's a pretty thing that we hear. So people, and they actually do find things out of a new batch of radios. So good question.
You know,
Joe,
and we've got it. Go ahead. Go ahead.
Well, I was going to address Joe's question about cable loss when manually testing radios. And yes, there is a way to do that. Joe, I'll send you a document or get a hold of you offline and go over that. But the 8800SX has an offset field in the generator and receiver tiles. And the 3920, of course, has its offsets configuration screen where you can input that data and then enable it to allow that compensation when manually testing. So again, I'll get a hold of you and we can go over that one-on-one as well.
Yeah, we've gotten a few questions about test cables. One of them was why we don't provide them. One of the reasons is because we have to triple the price on them. That's one of the reasons. And Mark's asking about the, let me make sure I can stay on your question here. Where do you order the test cables for the BK radios, the APX, and the Kenwood radios? So basically, you have to go to those providers, the manufacturer of those radios, or dealers would be able to get your dealers that handle those radios would be able to get you the part numbers for those, or the test cables. We can provide you the part numbers, but you'll have to get the test cables from the specific manufacturers in most cases.
Hey, Christopher, yes, both the 3920 and the 8800 save a text file on the unit. And both of those from within Autotest, if you look at the results screen there is a copy to USB button, and that will copy them to the USB stick where of course, you can take them to your computer and print them or whatever. If you're manually looking to view a set of results on the unit, there's a browse results function that you can use to view those. You've got my email address, and I'll send you an email as well. So if you'd like to go through that one-on-one, I can walk you through that process.
We have another question, kind of a timely question here. Has anyone reported problems on the Tate DMR radio auto test? We're having a problem with the power limits being set wrong. And we actually are looking at that right now. We've got the folks in New Zealand are bringing that up to us. As a matter of fact, I got a Tate radio hooked up to my 8800 right now. So we'll figure out what's wrong there. You should be able to adjust those limits, and it should use those adjusted limits during the test, and what we're seeing from the field right now that's not the case, which it should be. So we've just got to go in there and take a look at that and see why it's not accepting when you change the power limits on those radios. So they should have something for you soon on that aspect.
Mike, you mentioned the frequency response of your cables, and what you're seeing there is pretty typical. Yes, as you go up in frequency, your loss is going to increase in that cable. So in your case, you talk about VHF being about 0.1 dB, 800 meg being about 0.2. I would say that's pretty typical. And again, that's going to vary depending on how long the cable is. It's going to vary depending on the type of cable you're using. But the general trend would be the higher in frequency you go, the more the cable loss is going to affect your measurements.
And I see a question, is there a way to pull the test results out of the test set so that you can save them on a PC? And you can do that with both products. There's a screen you can go to and tell it just extract all of the test result files to a memory stick, and they're just text files. So, and then you can clear them out of the test set as well if you like.
Question here on loss in RF adapters. Mike, what do we usually, Dave, we usually consider that a 0.025 per adapter. Is that kind of what we rule of thumb?
Well, generally speaking, my view has always been that while we know that there is loss, and you know, if you had a VNA, you could sweep it or a network analyzer, and you could probably characterize that attenuator and see how much phase shift there is in it and all that stuff. In reality, bear in mind, what we're doing here are pretty simple measurements. We're just simply checking transmit power and sensitivity for the most part. And for what we're doing, the loss imparted by your connectors should not affect the results enough to be concerned about. If you have a connector that's dropping a half dB or a 1 dB, obviously that's a concern. But if you have a connector that's that has those characteristics, you probably should not be using it for anything. Does that answer the question?
Well, any loss for the RF adapters, if you don't know what it is, that when we use those calculators, we usually just say 0.0225 for the however many adapters you've got in. If you got 4 in there, 0.025 times 4, that'll probably get you close to what you're seeing. Yeah.
Mike, on your auto test, your APX 4500, there have been some changes to auto test for the APX radios, and I think the PA bias alignment was one of those things we had to make some changes on. If you don't have the current software, what's currently on the website on your test set already, I would recommend going ahead and starting there. And this is true for pretty much anything that you run into with regard to the APX radios or the Kenwood radios or whatever, one of the first things that you should probably do if you've determined that that there's some anomaly occurring, go out and make sure you have the newest software. I mentioned earlier we recommend keeping up to date on the auto test updates, and that's part of the reason why, is because if there was a bug that was causing a problem, and this could be a bug in the software in the auto test application. It could be a change in the radio's programming or the radio's firmware. We've had situations where the firmware in the radio changed, and all of a sudden the manufacturer, let's say they changed the way the serial number was reported to us, and now we're not able to read the band anymore. And so we depend on that information obviously to identify the radio and get the right specs loaded. And if that changes, we have to adjust our auto test application to accommodate that. Whenever we put new updates out there, there's always a reason for it. So that's where I would start. Like I said, I think we did have a PA bias adjustment bug here recently, but I believe, and Mike, maybe correct me, is that fixed in the newest release, or is that something that they're still working on addressing?
Is that on the APX?
Yeah, the PA bias alignment on the APXs.
Yeah, I think it's. I'm not sure if we've actually released it yet.
Okay, so that's something we may be still working on there, Mike. And
yeah,
so
it's very. I think it's in our ECN release process.
Okay. Thanks, Mike. Robert, when you put the cable loss in on the 8800, it does not need you to go in as a negative value. You can put it in as a negative value if you want to, but the 8800 is smart enough to figure out that the loss is going to be a negative, and so it will automatically assign the correct sign to it.
Eric was asking about the part number, the RF adapter for the Harris radios, and it's a little bit a different type of an adapter, and I did post that to all what that part number is, and that's a Harris part number. So you'd want to get a hold of them and see if you can get a hold of that specific adapter. Pasternak and other folks like that probably have those. I just don't know what those numbers would be. I just have the Harris number there. So Eric, I hope hopefully you can see that in the answers on the chat window.
So I know we're getting obviously well past an hour now. Why don't we do this? Bill and Mike and I will continue to go through these questions, and unless there's any other real pressing ones or real quick ones, Mike and Bill, I would say we'll wrap up for now, and like I said, if we'll address the rest of them offline, and like I said before, if you have questions, you think of questions later on, please feel free to drop us an email, and we can be sure to get back to you here in a little while. Okay.
Yeah, and like Dave said, if you didn't get your questions answered, we got your information here, and we will definitely get you an answer via email here shortly.
All right, Sarah, is there anything you want to say in closing?
Right. Oh, thank you everyone for joining us, and we'll get this presentation packaged up and sent out to you.
All right, thanks again, everybody. Have a good day.
Bye-bye.